Networking is about getting computers to interoperate. The very first thing for them to interoperate is that they need to be compatible in some sense at least. Let's illustrate incompatibilities, not necessarily in computer networks, but just to illustrate the problems that are introduced by incompatibilities. As an example here, I have an ordinary South African Type D electrical plug. This happens to be a cord that I have here, and on that end I've got a kettle cord, and so typical adapter you would use in South Africa to connect a computer to a wall socket. On the other hand, here I have the so-called sugar plug, or plug used very commonly in parts of Europe, especially Germany and surrounds. And this one happens to have a clover connector at that end, so different. And hence, the moment when one begins to travel internationally, you have to adapt the type of socket you have to the type of plug you have. And that is a nuisance. Why can't we just standardize it and use the same plug all over the world? In fact, if one looks at voltages, then in South Africa, Europe, and other similar places, we have electricity that ranges from about 220 to 240 volts. In the United States and Japan and a couple of other places, your electrical supply ranges from 110 to 120 volts. And that also causes problems. So why can't we just standardize it, and then one can plug in a plug into almost any socket, and off you go. You won't need adapters. And obviously that's what we want for networks. We want to be able to plug the one into the other, and not only should they fit physically, but they should be able to talk the same language, the same protocol, so that we can just let them talk to one another without worrying about any adapters or anything that needs to change the protocol or the physical fit of the plug. To illustrate the scope of the problem, consider this travel set. This is a set that one can get pretty far if one travels around the world, and will plug in a fair number of wall sockets. Not all of them though. So if we were to look at them in a bit more detail, there is the Schuko plug that we've just encountered a moment or two ago. As we've said, Germany and so on tends to use that. There is the British plug, the square pins that are used. There is the South African Type D plug, and so on. We can go through this list. There is a rather nifty design feature in this set, in the sense that the sockets are almost universal. So if I were to take a British plug here and plug it in there, it will fit. Okay, need a bit of pressure, but we'll be able to fit it if we try it. There is a plug that is commonly used in Australia, New Zealand, and again, if we were to plug it in there, it fits. So it is possible to build a sort of universal socket, although one doesn't see that in too many cases. In the introduction, we raised the question, why don't we just why don't we just settle on one plug and use that type? And there's an interesting answer to that. The fact is, there is an international standard plug, and South Africa has just decided to adopt that international standard plug. It is the Type N, And here you can see a socket for it. So there we have the type N plug, the new one that we're going to use in South Africa. And then there we have the old type D socket that we've been using for many years. The plug itself looks like this. So 3 prongs, and you can see them shuttered with plastic so that when you extract them, you can't accidentally touch the power pins and get electrocuted. The nice thing is that we are going to use an international plug, standardized by an international body, also standardized again in South Africa for our local conditions. But in principle, that would mean that we can travel anywhere internationally where they use this plug and just plug it in. The problem is there are only 2 countries in the world who are using this international standard, South Africa and Brazil. So anywhere else in the world, they're not using the standard, and hence the fact that we have just standardized our plug means more or less nothing. To make matters a little bit worse, just to show you the universal example that I've just used, and you can see that this international plug doesn't plug into it. So it is a new thing for plug manufacturers or socket manufacturers to consider. Now, to use this, obviously the 2-pin prongs that we tend to find on cell phone chargers and that sort of thing will fit there without any problems. And there is the South African new type N plug, and it plugs very nicely, nice tiny plug and so on. So it's a really nice plug, except that it being different from everywhere else in the world yet again, and we will need more adapters. The guess is that South African homes will switch to this plug type over the next 50 years or so. To the best of my knowledge, all houses built from 2021 onwards have to provide these new sockets. They will obviously still provide the type D socket, but they will then try also provide the type N socket. One of the interesting questions to raise is if one looks at the type J socket. Now that's the socket that is used in Switzerland, Liechtenstein and so on. It looks pretty familiar if one compares it to what I've just shown you with the type N. However, if I were to hold the 2 next to one another, you may spot some differences there. They are not exactly the same. The prongs are not of the same thickness. That central pin differs by 5 millimeters in its displacement. And if I were going to try and use this Swiss plug and plug it in the South African type N socket, it's just not going to fit. The holes are not aligned, so we can't plug this in. It is yet another standard to contend with. If you just begin to think about the challenges to switch every home in just South Africa to use these sockets, it means that every wall socket will have to be changed over time. It also means that every appliance will have to be fitted with a new socket, unless it is one that's not earthed, the two-pin sockets, as I've said, or 2-pin plugs that we encounter on cellular phone chargers, that sort of thing. They will be able to be used without any adapter. That's why it's going to take so long to switch. Now, this South African plug that I showed you a moment or two ago is actually used in a couple of other places in the world. Amongst others, it's used in India, but only for high-powered devices such as fridges and so on. So if one goes to a hotel, then you will find a similar looking plug used, but one that is smaller. So this is the sort of thing that you will use for ordinary appliances in your room. So your hotel room will probably not have sockets for a type D, but it will have sockets for this type of plug. In South Africa, many years ago, this was indeed the standard. In the 1950s, this is what we used in South Africa as well. And the house in which I lived when I studied, when I was at university, in fact was a rather old house, and it had an old wiring system. So I was quite used to using these plugs in South Africa. But we've moved away from them. We hardly see them nowadays. We do sometimes see them on light circuits. But the point then is twofold, actually 2 points. The one point is changing things to match a standard is expensive. And the other point is, if there is a standard, it does not mean that everybody will follow the standard, and the standard may become useless. One of the interesting questions is, who creates all the networking standards that we need? And it is an interesting list. It's a mixture of parties and organizations that one wouldn't necessarily have expected. So let's start with an old example. Those of us who are old enough to remember serial communications, those tended to use the RS-232 standard. RS, recommended standard, so in the name already you can see that it was intended as a standard. And the organization that created these RS standards was the Electronic Industries Association. In more modern terms, the Electronic Industries Alliance. And this was almost a club of producers of equipment. And whoever wanted to join the club could join the club. And they got together and they said, let's do things in this way so that our equipment would be able to interoperate. So it made sense for them to do that. This is not an example that we will encounter in the modern world very often, so don't worry too much about that one. Other examples originated in companies. If you think about the RJ standards, so a lot of these plugs, these tiny plugs that we use, are recommended jacks. So telephone line uses an RJ11, and network cables, Ethernet tends to use RJ45 and so on. We will refine all of that once we get to the appropriate point. But these originated with Bell systems. Bell systems in the United States needed to build a telephone network where they could plug telephones in all across the country, and they needed some sort of a standard. So this was an in-house development. Later went on to United States government agency and was controlled by the government agency and so on. But originally, at the very least, it was a company, Bell Systems. Now we can think whether Bell Systems as a government entity was really a company. But a lot of standards are de facto standards because someone did it in that way and it worked and they kept on doing that. As a slightly more modern example, perhaps, if you think about the PDF standard. PDF was developed by Adobe. It was really a proprietary system that they gave away. Eventually they handed control of the standard over to a standards body, but for a long time it was really a company that looked after that standard. We also have professional organizations, and one of the most prominent ones that we will encounter on a couple of occasions is the Institute of Electrical and Electronic Engineers, the IEEE. And the IEEE provided us with a fairly long list of standards that are still useful to this day, and they continue to expand on that list. So this is, as I said, a professional organization, engineers, computer scientists, who, as part of their profession, see the need to develop standards, and then they go about that. Then there are also quite a couple of bodies that have been established to create standards. Standards, for example, in a country where you want to ensure that certain things adhere to certain standards. And there we can think about South Africa, something like the South African Bureau of Standards. As a Bureau of Standards, it creates standards for almost anything you can imagine. We did talk about this new plug that we are going to use, and it was originally defined as an international standard, but the South African Bureau of Standards also published a standard that describes the size of the prongs and everything else in exact detail, how this would be used in South Africa. One of the things that you will see with a lot of these is that they use some sort of prefix. So South African national standards tend to use the word SANS in front of them. The IEEE standards we will very often refer to as IEEE standards. The company examples that we referred to pretty much depends on the company. The example that we referred to was the RJ plugs or jacks, recommended jacks, so RJ in front of them. And in the case of the Electronic Industries Association, the example that we mentioned was the RS. But obviously, especially if you talk about companies, they can use all sorts of other designations to indicate that they have created a standard. Just for the sake of filling this out a bit more, if you look at the British Standards Institute, then they would create standards that they tend to use a BS prefix for, and the American National Standards Institute, obviously that's the North American one, the one that's used by the United States, and they similarly would typically use ANSI in the prefix for their standards. You will also see a couple of standards that are published jointly by organizations. So there may be two prefixes that are used and so on. Let's not look at that into too much detail right now. We already pointed out that very often you do not want a standard to only apply to a country. In the case of computer networks, you want the standard to apply to the whole globe if possible, so that everyone can use it. We've seen that international standards like the South African plug, international standard that's not really used in other places, but if you're lucky, then you can get a standard promoted to a level where it becomes an international standard and where it is actually used, because typically there's nothing that forces the world to use these standards. You can force a country to use a national standard, but you can't force the world to use an international standard. So the two bodies that we are particularly interested in is the International Standards Organization. ISO doesn't really stand for International Standards Organization. It's more in the sense of ISO, like ISO bar or ISO level, where things are equal. But that's not really important to remember for our purposes. We might as well think about it as the International Standards Organization. Now, what they do is they have country representatives that are members of the ISO. So the South African Bureau of Standards, as one example, is a member of ISO. Another example, the Namibian Standards Institute. Also the other ones that we've mentioned, like the British Standard Institute and the American National Standards Institute, and so on. So there are countries who are members of the International Standards Organization. And you will typically, in order to get a standard on an international level, you will work through these national bodies and then get it to be accepted by the international community. They typically won't accept it as is, so there will be a very long process during which these are revised and so on. On the screen at the moment, you can see a screenshot from the ISO website, and you can see the first couple of countries listed, member countries listed. You can also see who the member organizations in those countries are. So what I suggest you do is go to the website and then just look at the various countries and in particular look at the bodies that represent them. Then there is another international organization who perhaps initially was not a proper computer network organization, and that is the ITU, International Telecommunications Union. Initially, they were called the Consultative Committee for International Telephony and Telegraphy. So you can see they were for telephones and telegraphs. Actually, that acronym is in French, and what I've just used is an English format of it. But if you want to look at the proper name of the CCITT, the old name that is no longer in use, you will see what it stood for in French. Now, in particular, also, we are interested in the ITU technical committees work because they publish standards. These standards are intended for telephones and telegraphs, if someone still uses telegraphs, but for a long time already, they've been publishing standards that deal with computer networks. And when we get to that, you will see at some point we're going to refer to all sorts of X standards. One that we already mentioned in one of these preface videos was X25. So that's an example of a CCITT or then an ITU standard. The same sort of situation applies. They have about 190 countries that are members. You can go and look at the ITU website. What you will see is that there are these countries that are members, but there are also 900 organizations, such as businesses or universities that are members. So they would all come together, obviously, to get some form of consensus from more than 1,000 bodies. Is really hard work. And there is a lot of work that has to be done in smaller committees to get it to the table eventually, where it can be voted on in a bigger context and become an international standard. We will every once in a while encounter the ITU, but the really important one for us is the International Standards Organization. We will refer to that in almost every video from this point onwards. This video was just a very short introduction to the reasons why we need standards and the problems that exist when one do not adopt standards. Now, in the case of electrical plugs, if you just stay within a country's boundaries, it doesn't matter if you are different from the rest of the world. Yes, tourists need adapters, but beyond that, you can get pretty far in that country. However, networks will not respect international borders, and we do need them to be standardized. And in the second part of the video, we briefly mentioned some of the bodies that issues standards, and not all of those standards are followed. In fact, the ISO network standard that we will use in this module heavily, as we've said previously, is a reference standard, or deemed to be a reference standard nowadays, one that shows us how things should be done in general, rather than a specific standard. So it is never used in its original intention, in its original role as a proper standard to build networks, but it still has a role to play. There are, however, some standards that have been proposed and have not seen widespread adoption, and sticking to one of those standards or trying to use one of those standards will simply not allow one to interoperate with other computers. Hence, we have to carefully look at the extent to which network technologies that we will talk about are standardized.
Music